Welcome to Study Loop.
Okay, so in this problem, first of all, the given values for R1, R2, and R3 are needed in the second part. So in the first part, we don't need those. But for the first part, what we need here is a conceptual understanding of how the bridge works. So we see that if the current is not flowing through the ammeter when the switch is closed, that means uh, there's no potential difference across B and D, because if there's a little bit of potential difference, then current will flow and the ammeter will detect. So since there's no potential difference across B and D, that means we can say that the from potential difference from B to A should be equal to the potential difference of A to D, and because that will make things zero on both sides, or the difference will be zero. And then by similar argument, we can say that the potential difference from B to C should be equal to the potential difference of C to D. So let's actually write those down. So from B to A should be equal to the potential difference from D to A. And if we use our Ohm's law, we'll have I3 times R3 equals to I1 R1. And from there, we get a relation of R3 over R1 equals to I1 I3. Right. And similarly, VCB, so let's use a different color there. Similarly, VCB should be equal to VCD, and from there again we use our Ohm's law, and we'll have I3RX, which is equal to I1R2. Yeah, and if we solve for Rx here, we get R2 I1 over I3, which is equal to R2 R3 over R1. So that's the expression for the unknown resistance. Now we know the formula. All we gotta do in part B is the values are given. We need to solve for Rx. So for Rx, let me write the formula again. It's going to be R2 times R3 over R1. It's going to be 972 ohms times 78.6 over 590 ohms, and that gives us 129 ohms. Thank you.